Hi, everyone. I think we're live. I see a little red button at the top left that says we're live. Hello, everyone. I'm David Tischler. I am a developer advocate at Edge Impulse, and I'm joined today by Mikey. Mikey, you want to say hello real quickly to the world?
Sure. I'm actually kind of upset you didn't say you were Davy Beavis, but
Davey Beavis joining
that's
live
all
from
right.
Phoenix, Arizona, as you can tell.
But yeah, so I'm Mikey Beavis. I'm manager of digital marketing and marketing ops at Edge Impulse. Fun fact, David and I started on the same exact day, but I'm 3 hours senior because I'm East
Yeah,
Coast.
that's correct. You're Beavis and Butthead live on the East Coast. I can see that you're joining from their living room. I don't know where Beavis
Yes.
and Butthead have gone, maybe to school or something. But welcome everyone to Impact Summit. This is Hackster's monthly showcase or spotlight on. I said Impact Summit. It's Impact Spotlight. I'm used to. Presenting or creating content for Impact Summit, which is the annual event. So apologies. This one is Impact Spotlight, and we're going to show off of three of the builds or projects from the community that have been submitted with some short videos. Before we do that, though, we've got to go over a couple of ground rules here, Mikey. We've got an awesome introduction from Pete over at the Edge AI Foundation. We'll get to that in a moment. And then, like I said, we've got three community submissions showing off some work that they've done surrounding this month's theme, which is Edge AI. And we'll get to those in a bit as well. Behind the scenes, we've got Jesselyn. I don't know if she wants to pop in and say hello. If not, it's just going to be Mikey and I hosting or emceeing the show today. But it's worth pointing out that I'm actually in my Hackster shirt today. So we're not here on official business, Mikey. We're not here wearing an Edge Impulse hat, even though we will show a couple of projects that do use Edge Impulse. But we are just community members hanging out. If you do have any questions or comments, feel free to put them into chat. I haven't seen anything come through yet. I don't know, Jesselyn, if you need to approve comments or anything. I don't know, but I haven't seen anything yet. So if you're out there and you've got a question for us, certainly just drop it in and we can see what we can do about getting it answered. I think that's about it. Mikey, I noticed we didn't get you enough swag for this, though. I've also got my Hackster coffee mug ready to go.
I was gonna say I have zero swag, but you did promise me a gallon of margarita, so
I
I'll settle
did
for that.
promise that I would pay you in a gallon of margarita. I don't even know where to purchase a gallon size margarita,
Or
but
3.8 liters for the metric
3.8
liters.
for, okay.
Yes, for the joke to land, I did do the
You
conversion.
you did the conversion, so it's 3.8 liters of margarita. I think I can probably find 1 liter bottles of margarita, so we'll get you 4 of them.
Perfect.
Let's see here. Oh, Jesselyn says comments are live. No gatekeeping. Okay, so here they come. Hey, Goron, good to see you. And Mike, you'll get your swag. That's probably Ginger. Yeah, she took care of me. I got some stickers, I got a T-shirt, and I got a coffee mug, so I'm in good shape. All right, let's see here. I think we've made it through all of the rules. Mikey, are you about ready? You're not expecting Beavis and Butthead home anytime soon?
Nope, I think we're good.
Oh, nice. And I see a nice cactus. Yes, I'm in Phoenix. So I'm broadcasting live from the desert. It's not too hot here today, actually. Mikey, I heard earlier this week it was pretty warm where you are.
Yeah, it finally broke. But bad news is now I don't have an excuse why I'm so sweaty. So
Yeah, you're
I was
just
able to.
sweaty.
Now I'm just sweaty.
You had an excuse previously. Yeah, it's cooler here than it was there.
Hmm.
Will AI? We got our first question. Will AI take over all jobs? Conchi. You know what? I'm not sure, Akanchi. It might. You probably do want to prepare for an AI takeover. I think it would be good to get prepared for it. I'm not 100% convinced, but I think I'm about 95, 96% convinced that yes, AI will take over all jobs, and well, we'll just hang out all day as humans. That's great until they eliminate us. All right. Let's get going. Jesselyn, you want to kick us off with Pete's intro, please, to Edge AI?
Hey, this is Pete Bernard, CEO of the Edge AI Foundation. I just want to talk to you for a few minutes here about Edge AI. You're about to see some really amazing projects from Hackster and the Hackster developer community here. And they've asked me to say a few words about Edge AI. And I assume that since you've tuned into this, you're interested in the topic. It's really become quite a firestorm of ideas and innovation, especially in the past year. We've really found some amazing solutions around bringing the AI workloads to where the data is created. That's really kind of the essence of what Edge AI is. It's AI in the real world. It's AI that's happening in agriculture, in healthcare, in retail, in water systems, around your house, in vehicles, in robotics. It's AI in the real world. It's not AI happening in a nuclear-powered multi-tenant data center, although plenty of good workloads that are happening there in training. But really, the inferencing that's happening in the real world is super critical, and that's what Edge AI is all about. In fact, there's many flavors of Edge AI. It's sort of like it's like an ice cream shop with lots of flavors. You've got AIoT, you've got TinyML, you've got physical AI, you got generative AI at the edge as well. You've got neuromorphic computing. So there's lots of different ways that people are innovating to run AI workloads in these resource-constrained environments. And it's really fantastic to partner with Hackster to do this. The Edge AI Foundation, we're a nonprofit. We're made up of 50 plus companies around the world and academia, really trying to advocate and educate on Edge AI, trying to help people understand what it is and work collaboratively in working groups to accelerate Edge AI. We just had a big generative Edge AI live stream, a 2-day long kind of marathon live stream on YouTube. We do live streams on YouTube all the time. We have an event coming up in Milan, July 2nd through the 4th, kind of a 3-day Edge AI jamboree for the European community. That's going to be fantastic. Something like 40 sessions and 8 workshops and panels and good coffee and things like that. We had one in Austin, Texas as well. And yeah, so it's a great community to become a part of. You can come to our Discord server, and all that stuff's available at our website, edgeaifoundation.org. But Edge AI itself is really becoming a thing. Now, you could also talk about Edge AI down to the sensor level and running 10 kilobyte models in sensor networks, and companies doing neuromorphic computing and ultra low power things, and also running it up to on-prem servers that are running AI workloads locally. The thing that the phrase that keeps resonating with me is that sovereignty is currency in the AI market. No matter what country you're in or what kind of business you're in, the ability to have control over your data, control over the data sets, the models that you're using, running it in the hardware that you own, that you have control over, that's really important. And in fact, in some cases, it's critical for success. So we're really excited about how AI is becoming democratized and really strengthening that sovereignty ability to use AI anywhere that you need to run it, at whatever cost you need to run it. Now, they say the gravitational pull of AI toward the edge means that things are running at lower power for lower cost and greater impact. That's a really important factor when to run your AI workloads. And so I would consider this: when you're thinking about solving problems with AI, think about where the data is being created and how close to that data can I get with my workloads. Can I run my AI workloads right at the sensor level when I'm collecting data? Can I run it at the camera level, at the gateway level, at the on-prem level first, before I end up shuffling a bunch of data up to the cloud? So that's really what Edge AI is all about. We're going to see some amazing solutions today. I encourage you to go to edgeaifoundation.org or find us on YouTube under Edge AI Foundation. Lean in, join the community, give us your ideas, join the movement, and appreciate your time. Thanks.
All right, are we back? I think we are. Mikey, it looks like you've moved.
I moved to the Simpsons household.
Oh, you moved to the Simpsons household? Okay, all right. Yeah, it looks like everybody's out, for work and school there as well. Good. Well, I also changed locations in that quick 3 minutes that Pete was speaking. I actually traveled to a different desert. I've gone from the Sonoran Desert over to the desert of Egypt now. And I see we had another person come in. Hey, Maker Brains is in. That's Mukesh came in. Great. I was listening to Pete speak, and he covered a lot of interesting and great things there. The big takeaway was, of course, the coffee. He said there's going to be great coffee in Milan. I don't know that I've ever been to Milan, but Jesselyn, can you bring my screen share in? Because this event that he was speaking about actually looks really, really cool. So this is the Edge AI Foundation event happening July 2nd through 4th. So for those of you in Europe or willing to travel, this looks like it's going to be a really, really cool event. I know they've run this one in Milan for a couple of years. I'm wondering, this might be their third. But I know they bring together the community. They do. They bring some academics and researchers. They bring some industry. They bring some developers. So if you are in the area, I highly suggest popping in for a visit there. All right. And let's get this off the screen, if you don't mind, Jesselyn. And I think we can probably get into our first community spotlight. And this one is a project that I remember being built last year. It looks like it's been revised by actually one of the Edge Impulse Expert Network members, Ronnie Bandini. And this one is doing, an interest. I mean, he'll show it in a moment. I'll let him walk through it. But helmet detection for motorcycle riders from a public safety perspective, and in some cases and territories, legality as well. So if a motorcycle rider is not wearing a helmet, the traffic camera can identify that and will stop traffic until they put their helmet on. Usually, they're holstered on the side of the motorcycle or on the back of it, and the rider doesn't have the helmet on. I'm like, just put the helmet on, it's right there. So, Jesselyn, if you want to hit play on this one, we'll let Ronnie take it away.
Hi everyone, my name is Ronnie Bandini. I am from Buenos Aires, Argentina. I work with artificial intelligence and LLMs, and I'm also the founder of the Contracultura Maker initiative. The project I am showcasing for Impact Spotlight is named No Helmet, No Green. Back in 2021, Onda Motor Argentina released the Awareness Traffic Light campaign to promote motorcycle safety. The concept was simple but striking: a smart traffic light that only turned green for riders wearing helmets. Let's look at the video.
Onda Safety presenta el semáforo concientizador. Un semáforo que cada vez que se pone en rojo activa un sistema de reconocimiento facial que detecta a los motociclistas que están circulando sin casco. Y hasta que no se ponen el casco, el semáforo no cambia.
As a motorcycle rider and someone who works with artificial intelligence, I was immediately intrigued. What kind of tech did they use? Was there a trained model? Was it written in Python? Where were the cameras placed? And beyond the tech, was it ethical to keep helmeted riders stuck at a red light just to make a point? I looked for technical details but found absolutely nothing. So I thought, how hard would it be to build my own version of the Honda awareness traffic light? Detecting riders without helmets using rule-based programming is a nightmare. You need to take thousands of pictures, hire specialists, and write endless rules that would eventually break. With machine learning, you gather a dataset or generate one with Gen AI, you train a model and let it find patterns you never think to define manually. Since I don't have access to a real traffic light, I created a scaled down version using Lego figures. I took around 60 pictures with and without helmets using the Open Camera app, which can automatically take shots at intervals. Then I uploaded all the pictures to Edge Impulse. Edge Impulse is a platform for edge-based machine learning, meaning the model runs right where the data is generated. It's packed with tools to label, process, train, test, and even to deploy the models, and it's free for developers. I created an impulse using 96.96 pixel images, added an image processing block, and also an object detection learning block with two labels, helmet and no helmet. After generating features, I trained a neural network with 60 cycles at 0.001 learning rate. I also checked data augmentation, and the result was a solid 95.2 F1 score. F1 score is a metric that balances precision and recall. It tells you how well your model is actually doing beyond just raw accuracy. For deployment, I use Texas Instruments AM62A evaluation board. I plugged in a cheap USB camera, and that was it. Then, compared to the Raspberry Pi, the AM62A isn't great for beginners. You don't just plug in a monitor and type Linux command. It runs a custom OS, Arago, and the HDMI port only shows demos of pre-installed artificial intelligence applications. The board captures images and performs inference. Then an intermediate PHP server running on AWS Lightsail receives the helmet detection results and stores those detection scores inside a text file with ini extension, which is then queried by the traffic light system. I tested manually at first using a local browser. Then I check that the ini file actually is updating the score. This example only supports one intersection. If you have multiple traffic lights, you of course need to include an ID also and add some security layers there. For the visual display, the actual traffic light, I used a Unihiker board made by DFRBot. It's kind of a Raspberry Pi with a touch screen, sensors, and a pre-installed OS. I connected the Unihiker using a USB-C cable. I accessed the web interface using an address provided by DFRBot. There I set up the Wi-Fi, I got the IP, I used that IP to upload the files using FTP. And I also placed the traffic light images into the images folder. The script cycles through 3 PNG, red, yellow, and green, and before switching to green, it queries the server. If the no helmet score exceeds a set threshold, a no helmet, no green image is shown instead of the basic red, yellow, or green light. I also modeled and printed a small base for the Unihiker using Fusion 360 application. After sharing the project, I got a bunch of messages, mainly from artificial intelligence enthusiasts and makers, but one stood out. It was from a local in Campana, the town where Onda shot their ad. He told me he was there on filming day and saw that the traffic light were just green screens, no cameras, no artificial intelligence, just a video shot. So was Onda's campaign real? I'm not sure. I think I was not, but it's not so complicated to build such a system. Whether it should be used is another debate. As a maker, I'm proud to share a working prototype that combines artificial intelligence, different boards and services. So this is all I have for today. Thanks for watching. You're welcome to clone the original Edge Impulse project and download all the Python files.
All right, perfect. Mikey, have you moved yet again?
We're making great timing.
We sure
Now I'm in
are.
Family Guy, and you made it all the way to China.
And I made it all the way to China. That's right. We are touring I'm touring the world. You're touring the cartoon world. I love it. I love what you've done with the place there. All right. So that was a really cool project. I remember, like I said earlier, I remember when Ronnie wrote that up. It looks like he's added a little bit to it. And that TI board he used is actually a really good piece of hardware for developers that are building products or things that are going to go from prototype to production, because those TI chips are certainly enterprise grade, industrial strength, and you can get them in SOM form factors and things that can be embedded into, custom pieces of hardware or things out in the real world. Up next, let's take a quick look at what we've got. Where did my little cheat sheet go? Second on our agenda is Tiny Prism Labs, a JIF. And a JIF has, now this one I did not see originally. I try to keep a close watch on the Hackster machine learning channel, but I missed when this one came through. And this is Edge AI for predictive maintenance in, I don't know how to say this exactly, so somebody might need to correct me here, but Tormach CNC, which is a machinery similar to like if you think of like a laser cutter or a 3D printer where you have, X and Y axis, and its CNCing is typically done with like a rotary drill, if I understand correctly. And next location, Taj Mahal, India. Or that's not a bad idea, Mukesh. Maybe I'll have to go download a quick background and get on an airplane. All right, so Jesselyn, if you want to kick off our next one, I think we're ready to go.
Hi everyone. So this is Ajit and I'm a co-founder of Tiny Prism Labs Private Limited. So we are from Manipal, which is situated in southern part of India. So I would like to thank the Hackster community for giving this opportunity for us to showcase this technology that we are working in Edge AI domain. And also happy to represent our work, that is Edge AI for predictive maintenance in Tormach CNC in the Impact Spotlight. So talking about Tiny Prism Labs, we are a deep tech startup company specifically building an Edge AI solution, which is ultra efficient, battery powered, on-device ML intelligence for the sensor-based data. It can be from accelerometers to the camera. Our expertise span in edge computing and on-device ML, along with building embedded systems and also building custom ML algorithms to run on a device which is capable of giving you the real-time predictions in order to take real-time decisions. So talking about the problem statement, Back then, industrial manufacturing relies on the scheduled maintenance, which is like the routine checks, human inspections as such. Today, still there are 40% loss that are happening in manufacturing industry that is due to unplanned downtime. So there are many IoT solutions that are there which overcome these problems, but still it adds the cloud dependency, which is like cloud-based analytics and also high bandwidth requirement as such, which again adds the operational cost, and also it incurs delay in the latency. So now in Tiny Prism Labs, we wanted to flip this model and come up with an Edge AI solution which really helps the predictions to happen instantly to take the real-time decisions. So our design is an efficient battery-powered hardware enabling on-device intelligence using real-time sensor data. So here we are adding our sensing component to a CNC milling operation in order to get the data set and also the real-time insights. So we do build a custom ML algorithm on top of the data that is collected, along with the feature that will be extracted from the data that is collected, and deploy the trained model on a same device in order to get the real-time predictions. So in the subsequent slides, we're going to see how exactly this works. So to prove our use case in Edge AI field for a predictive maintenance, we have chosen the CNC machines, which is specifically provided by a Tormac company, which is actually a US-based company specializing in affordable and user-friendly CNC machines. So they run on a G code and their performance relies specifically on the spindle of the milling operation. So Tormac is a US-based company building the affordable user-friendly CNC machines. The hardware that is chosen for this operation to happen is ZioBLE Sense. So why exactly this is, we do have the MCU NRF52480 and also inbuilt IMU sensor is available, which readily captures the movements or the vibrations. And along with this, we have attached the lithium polymer battery, which is USB-C controller, which has Type-C connector along with the charging controller. Finally, we are here where we are mounting the hardware that is prepared on the spindle of the CNC machine, and you can see there is a device that is strapped on the spindle which highly captures the vibration of the milling operation. So the axis that I've been chosen is x-axis, and the z-axis will be able to capture from the vibration, and the data has been collected in different RPMs aligned with the G code that is written, and this is how the data is collected and this is how the mounting is happening. So after mounting, after capturing the data, what next exactly, right? So here is how the process that is being followed in order to get the real-time sensor data and in order to get the real-time predictions for the data that is collected. So once the data that is collected, we need to see how the data tells us a story, right? And that's where the feature extraction process happens. So here we have used statistical methods in order to extract the features from the data that is collected. The trained ML model, which actually classifies the real-time sensor data into normal or abnormal or anomaly, is being converted to a format where it can accept or where it can run in a microcontroller is by using TensorFlow Lite framework. So this is used to optimize the model that is being trained in order to run on an MCU level. And this is what we have done in order to run the model on an MCU. So finally, the data or the model that is being trained is being deployed it onto an MCU level, which is on the ZioBLE Sense, which is capable of taking the data in real time, analyzing the features by the feature extraction algorithm that is being developed, and it will go through the data that it will go through the model that has been trained in order to give you the prediction as normal or abnormal. And there is a code written on top of it which sends an alert to a respective department. Coming to the next steps, we are here inviting the industrial partners, OEMs, automation integrators to deploy our Edge AI work or the Edge AI technology that we have developed into major key sectors like the use cases that we are identified, one of the main thing that we explained now is CNC milling, also the lubricant and chemical plants. So thank you for watching out our innovation thought process towards the edge AI and also towards the predictive maintenance. So you can go through our project page in the Hackster to know more about our works, and also follow our page in LinkedIn to get more exciting information as well. Thank you very much.
Okay, we're Mikey, where are you now?
I'm walking out. Nobody's been home at any of these places. I'm now
Nobody.
in
Yeah.
Seinfeld's apartment.
Jerry's not there. Where's Kramer's not on the couch?
If
Nobody's
the stream
there.
ends, it's because I was arrested for a home invasion in one of these places.
Well, I actually hopped a flight down south. This is the base camp or whatever they have down at the South Pole. I'm in Antarctica now. It's nice and chilly here, which is a good break because I've been, spending too much time in the desert. All right, so that was a really cool use case. Predictive maintenance is actually something we see quite a bit at Edge Impulse when it comes to Edge AI. We see motors, we see pumps, we see infrastructure, we see manufacturing. I don't know that we had specifically seen anything CNC related, but it's definitely a perfect use case for inference right on the machinery. That will take us into our third and final project for the month, which, let me get my notes up. This one I remember seeing as well. So this one is from another of the Expert Network members, Solomon. And this one is an AI security camera for vehicles. And I just caught up with Salo not too long ago on a call. It's always great to see what he's up to. There's some other projects in Hackster. If you go search for him and his profile, I'll drop the link in a moment. He does some really, really interesting work. One that I was just reading about was on-device training. Kind of like Pete mentioned in the beginning. Mikey, when we train models at Edge Impulse, we train them in the cloud, probably these clouds right here that are above me. We train them in the cloud, build the model, but then the model runs on the device at the edge. The device at the edge is typically low power and it can run a model, but not really train a model. And sure enough, Salo was doing some experimenting with attempting to train models on microcontrollers. It's like fascinating research stuff. So I'll grab the link and drop it in. But this project in particular that we're going to show is AI security camera. Let's go ahead and take it away, Jesselyn.
Hello everyone and my fellow Hacksters. Thank you Hackster for inviting me to this month's Impact Spotlight to talk on my project on smart vehicle monitoring system. My name is Solomon Muhunyo Gitu. I have a background in mechatronic engineering and I've always been fascinated about embedded systems and in particular how we can use small low power microcontrollers to come up with so many amazing projects. I work as a researcher and also developer at Wazia where we focus on deploying and developing IoT solutions such as our own in-house softwares and also hardwares such as development boards, LoRaWAN gateways, and also sensor nodes. And using these technologies, we promote capacity building across Africa, Europe, and also Asia so that the local workforce can be equipped with the skills that they need to be job ready and also to develop their MVPs using the cutting edge technologies. I also contribute to the Edge Impulse Expert Network where I share my ideas on amazing use cases and also research. You can find my projects on Hackster and they're basically looking at AI solutions from a perspective of MVPs, such as a wearable, or it can be from a research perspective, such as how can we train AI models on a microcontroller. On this project of the smart vehicle monitoring system, fun fact, I came up with this project after witnessing potential battery theft from a lorry. If you look at how a lorry is designed, the battery is normally located outside of the lorry. And so one day someone had spotted a new battery on a lorry and they wanted to steal it. But luckily there was someone passing by and they looked at the scene and they could see that clearly this is someone trying to tamper with the battery from a lorry, and they don't look like they are the owner um, of the vehicle. So this passerby raised an alarm, a crowd came, and the thief was stopped and the battery was not stolen. So that got me thinking on how security cameras, most of them, they just record the scene, but they've not been developed in a way that they can interpret what they're actually seeing. So this formed the goal of this project on how can I create a smart camera that can um, run an AI model fully at the edge on the device itself. And the AI model can detect visual cues such as someone trying to tamper with the car tire, someone trying to tamper with the windows of the car. And this device also needs to support low power consumption. It needs to support wireless connectivity such as Wi-Fi or cellular, so that when the model detects these events of potential window theft or potential tire theft, then the device can send an alert such as an SMS message or an email so that someone can intervene. And the device also needs to have a small form factor because it's just difficult to work with very big computers such as a desktop and trying to mount it somewhere so that it can be working as a CCTV camera. And following the goals of this project, I chose the Arduino Potenta X7 because it meets the requirements that I had for my project. And the solution itself uses the Potenta X7, which is running an NVIDIA Tau model that has been trained to detect potential tire theft or potential window breaking attempts on a vehicle. And once these events are detected, the Potenta board, it automatically sends an email to someone so that they can intervene. Looking at the components that you will need to develop this project, I advocate and I promote open source solutions. So the components for this project, they are low cost, they are open source, and most of them, apart from the Potenta board, are free. In terms of software, you'll need the Edge Impulse Studio, which we will use to collect data from the Potenta board itself, train a model, and then eventually deploy the model to the Potenta board. And during this deployment, this is where we use the OpenMV ID so that we can customize the deployment, let's say software or code that is running on the Potenta so that it can send an email. Looking at the hardware, you will need a camera. Um, on the Potenta Vision shield, which is like a module that you connect to the Arduino Potenta board. You need your personal computer. It can be a laptop, it can be a desktop, so that you can train the model using the computer and also upload the inference code back to the potenter. If you intend to use Wi-Fi functionality, you will need to have a 2.4 gigahertz Wi-Fi antenna that you need to connect to the potenter board so that it can um, um, connect to a Wi-Fi network. You'll also need a USB-C cable for programming the potenter. And in this case, because I started this project from a research perspective, so I also use the USB interface to also power the potenter board. And following this, I also designed a simple enclosure for the potenta, and the design files are available on printable.com. The design and construction for this project is actually very simple, and it's a testament of how advanced the hardware and software um, uh, technologies have come, because we only need the Arduino potenta board with a vision shield, and that's it. That's the base of the smart camera. Other than that, we can enclose the potenta board in using the simple enclosure that I created, because we intend to put this camera outside in the real world so that it can be mounted at a parking lot and monitor a vehicle. Because I started this project from a research perspective, I enclosed the potenta with a simple enclosure that I designed, and then I mounted it on a tripod, and then I faced the tripod to a vehicle. And I used this setup for collecting data by acting out that I'm trying to interfere with the tires of the vehicle, or I'm trying to interfere with the window of the vehicle, and then training the model to understand the environment. So I use this setup for both testing and also deployment. Following the hardware design of this project, which is merely just using the potenta board, in terms of software, the project it heavily uses the Gimpus platform to collect data straight from the potenta board to train a model and also to deploy the model. I also explored various models that we can use, such as NVIDIA Cow, MobileNet V2, and also visual anomaly detection, trying to understand how each of these model performs, how does each of these model understand the environment, and also because we intend to deploy this model to the microcontroller, which is the potenta. In this case, at the microcontroller level, we are very constrained in terms of the resources, such as RAM and also flash. And normally, when deploying AI models to the microcontroller, it's always a challenge, because you need to optimize the model so that it can run well at the microcontroller level. So I explored what are some of the challenges and also what are some of the limitations. Um, that can be faced, particularly in this project. So there are challenges such as for the MobileNet V2 on the Gimpus platform, it runs very well. The testing part, the model performs very well. But then now when we deploy it to the microcontroller, because the model needs to be optimized, that optimization, it sometimes can lead to a significant loss in terms of the accuracy of the model. And so these are some of the challenges and also the areas that I also try to explore when developing this model. But eventually I settled on the NVIDIA Tau model, and using the GPulse platform, I exported the model as an OpenMV library, and I used it to create a custom code that gets the results from the OpenMV camera, and considering what the model predicts, such as if there is a potential tire theft or if there is a potential window breaking attempt, then the model it automatically sends an email to a designated email address. Looking at the next steps for this project, it will be interesting to support other alert features such as sending an SMS message. You can also connect alarms to the microcontroller, such as when these events are detected, then an alarm can turn on. We can also support other environments, such as during my testing, I only train the model to detect suspicious activity around one vehicle, and the model was trained to only understand that environment. But when you look at it from a real world scenario, there are so many vehicles that are parked. There are different, let's say, models of vehicles. It can be a sedan, it can be a van, it can be a lorry, it can be a bus, and there are also other activities that can happen to a vehicle, such as there can be attempts to steal the vehicle as it is on its whole, to steal other things from the vehicle, such as the side mirrors, such as the bumper, such as the headlights. So in this case, there is need to also train the model on more data, which captures various environments and also various visual cues that models need to be trained to be effective, such that we can um, 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 take this project to the next level. Another thing is that considering that I use the Potenta H7 board, I could only implement this project during the daytime. The camera does not support night vision functionalities, but looking at it from a real world perspective, CCTV cameras, they need to operate both during the daytime and also both during the night time. So in this case, it's also a must for the camera to also support night vision functionality so that it can be effective to be used in a real world setup. And that's it about my project. You can find a comprehensive description and also analysis of some of the choices that I made when developing the models and also some of the considerations that were made. The link is shown on the screen, and you can also find the source code on GitHub. And yes, that's it about my project. Thank you very much. Bye bye.
All right. Well, thank you, Salo. Great presentation, and I also really liked how much detail he put into the presentation and that talk, because he really does a good job of going through the thought process, and then, like he spoke about at the end, the limitations as well, and areas for improvement. Okay, Mikey, we've made it through all of the community presentations. Are you ready? This is the section where we do the interview, although I see I'm getting blocked out here. I've got my notes ready. Are you prepared for
Go for
the
it.
interview?
Go for it.
I'm teasing you. I'm teasing you. No, I'm not going to interview you. But I do see that you've made yet another location change. And I'm wondering if our younger viewers out there are even going to recognize that living room. So if anybody,
Yes, I'm channeling my inner Al Bundy and
yeah,
married with children.
yeah, married with children, Al Bundy. That goes way, way back.
Yes.
Oh no! First time commenter, long time listener. Thanks, Artie.
That's the trio. Artie finishes the trio.
The third
Artie,
Beavis.
Mikey, and Davey Beavis.
First time commenter, long time listener. Well, welcome to the show, Artie. Happy Throwback Thursday is right. Yeah, so what is that? Yeah, nobody even knows where you are anymore, Mikey. All right. Well, we'll skip over the interview section. Mikey, you're off the hook. You survived
Perfect.
it. I have to admit, you lived through it. This is a low pressure community hangout. Next time we'll put you in front of a live studio audience.
Oh yeah. Yeah, normally I'm the one that gets to produce and hide backstage. So.
Yeah, this time Jesselyn got the honor, got the luxury of hiding backstage. All right, folks, but in all seriousness, yes, we're coming up on the top of the hour, so we will close this out. The next Impact Spotlight event is Thursday, July 31st, and that one will be focused on motorized movement. So think about things like vehicles, mobility, autonomous vehicle, autonomous rover, bikes, anything in motion. Which more and more, quite honestly, have an edge AI component to them. So we'll see what the community chimes in with. And then one more quick announcement coming up at the top of the hour. I think in 7 minutes we go back to back here. Not we won't be hosting, Mikey. Don't worry. I know I got you nervous for a second there. Robert Wolf will be hosting. Sachin, I don't know if I'm pronouncing that right. Apologies if not. Sachin Soni, who goes by Techie SMS in the community, and he does some really cool builds and projects as well. I was just reading this one that came out last week. He built a GPT-4o smart camera. It's pretty impressive build. So I don't know if this is exactly what he's going to be walking through, but definitely tune in and check that out. I think we got all of the links into the chat along the way. Jesselyn, if there's any others you want to drop in, get them in there now. And then the final closing remarks are the same as always. Make sure to subscribe to the Impact Spotlight newsletter or the Hackster newsletter to be notified about any other upcoming events. Make sure to always click all of the bells. Any bell you see on a Hackster channel, click it. Click it as many times as necessary. Make sure you're ringing it. And I think that should do it. Anything else from your side, Mikey?
No, I just have to say that I love seeing what people can do and push the boundaries of what's possible on the edge, because it makes my job easier when it comes time to do the marketing of
do the marketing and do the
Jim
content.
So,
Yeah.
Yep. So thank you to the community.
Yeah, likewise, quite honestly, I end up showing off a lot of their and live on the edge. That's definitely Ginger. We're living on the edge. All right, folks, we'll have a great rest of the day. Hopefully we'll see you back in 5 minutes for Robert and Sachin. Have a good one. Bye, y'all.
Thanks.